So now our task, well, I need three more forces, FBE, FBD, FDE, and I'm going to move on to another joint. Um, Interesting. I think, so I'm looking at these joints, I'm thinking, B is probably the one I'm going to need to look at, and here's why. So at joint B, we have the force, sorry, let me get my pointer, BC and AB. Now they somewhat counteract each other. Are they equal, AB and BC? AB was 77.5, BC was 105. No, so they're not equal. So this one's winning out on this joint. So there must be some other force counteracting the excess on force BC, or I mean on the joint, because we have AB going to the left, BC pulling to the right, and they're unequal. This one's smaller than this one. So this one wins out. So if there were no other forces, this joint would be moving to the right, and I need something to counteract it. Well, the only other x direction would be this, right? Because this has an x component, and it would have to point opposite this. This is the winner, so it has to point opposite. So I know then that that must work that way, and so I'll draw this, and that means this BD is under, it's pulling, so it's under tension. So let's focus on joint B now. You just have to go look through and see what you have. And then, well, I know that BD in the x direction, force of BD in the x direction, that's, well, I can figure that out right now. That's going to be just the excess from BC and AB, right? So that'll be 105 BC, 105 pounds minus the 77, because those 77.5. Because remember, the sum of all the x direction forces have to be 0. So if I added this one up and this one up, the x component here has to counteract what's left over. So that's how I get FBDX, and that's 27.5 pounds of force. Okay, and then, well, how do I get the actual BD force? That, I guess I have to use some SOHCAHTOA stuff. So I think I need this angle. I think I need that angle. So how do I get that angle? Well, I know that from my picture, that angle is just the same as that triangle angle, right? And we have, this is 20 and 20. So it's 45 degrees, right? If they have an isosceles triangle, it's 25 degrees. Or sorry, 45 degrees. So that's easy. And since I'm trying to find the force within BD, I'm going to draw that force. We know it's going that way from joint B, right? I never did my free body diagram. Maybe I'll do it here. So FBDX, that's here, right? There it is. And that was 27.5, 27.5. And we have this angle as 45 degrees. And this is a right triangle. I have adjacent, and I want the hypotenuse, so I can just use cosine. Cosine of 45. That has to equal the adjacent, 27.5, over the force within BD. Cool. And then I switch those two. So I have FBD equals all that stuff. So the force within BD is 38.891. I'm rounding to 3 decimal places. So that's cool. We're getting closer. 38.891 pounds of force. That's FBD. 38.891. And what do we say? BD was in tension. Under tension. Cool. So we have that. Just looking at my free body diagram, I have a y component that's going this way, so that means this has to be pointing upwards, right? I have the y component of BD. That's going to be the same as that force, just because they have to counteract each other. So I know that this is that way. Oh, that means this is that way. So this is under compression. That part, BE, is under compression. Now I can find BE. Oh, we're getting really close. So let's see. The Y component of this force, well, it should be the same as the X component, because this is a 45, 45, 90 triangle. So that would be 27.5. Right? So that means this is going upwards at 27.5. So that means the force within BE, FBE, is 27.5 pounds. Sweet. One more force, 27.5 pounds. And this was under compression. BE is under compression. Oh, we're rolling, man. We're rolling. FDE. I guess that's the last one. I can focus on joint E, or I could focus on joint D, I guess, right? Because I know almost everything about it. You know what? Let's see. It doesn't matter.